Okay, so now we're going to go on to section 2 homework, and we'll start with chapter 3. So as before, you go into the blackboard and we're going to open up the Cengage, so that's Econ 212, it will be there, and we'll let it load for a moment. We're going to select section 2 material. Remember, it's put in the same format as the blackboard, so we'll click section 2 and we'll go to chapter 3. So chapter 3 is looking primarily at trade. And as before, we'll go down to the homework, and the ones that you need to be concerned with are the ones that say counts towards grade. You can do the practice, it's always good to practice, but these are the ones you must do for the grade. So we'll click on problems and applications, and there'll be just a few questions. Okay, so we'll start with question 1 to get going. All right, so on this particular question, you can tell it's asking you to form a production possibility frontier. So we use those in trade as we also used in section 1 material. So the question reads as follows. It says, Yvette can read 40 pages of psychology in an hour, and she can also read 30 pages of history in an hour. Okay, so they're giving you in increments of 1 hour. And then, this is very important, it says she spends 4 hours per day studying. What you want to do is figure out the total number of pages that she can read in the allotted time she's given to studying, which is 4 hours. So we know for psychology, for 1 hour, she can do 40 pages. So if she took all her time, the 4 hours that you've been told she puts to studying, and she just studied psychology, with 4 hours, how many pages of psychology could she read? And then the other extreme point would be, with 4 hours of only studying now history, so rather than studying psychology, she only studies history, she can read a total of 30 pages every hour. So for 4 hours, how would you get that? And then what you'll do to be able to draw your production possibility frontier, you'll take the two extreme points and plot them. Use your clicker, get the dot wherever you think the maximum, and then you can start moving the second one around where you want to put the second one. So that's how you'll do that. But that's not how it's going to look, by the way. And then the next part of the question says, Yvette's opportunity cost of reading 90 pages of history is blank pages of psychology. So again, you have to be very careful here, because now it's asking for 90 pages. And the information you were given was in increments of 1 hour. And then here what we did is we took the maximum points based on the total 4 hours. So what you want to figure out is, how many hours would it take Yvette to read 90 pages of history, and that would then tell you what she would be giving up in that same period of time for psychology. So just be a little careful on that question. The next few questions are specifically looking at trade and how we can take advantage of trade. But it's really important to separate in your mind the difference between absolute advantage and comparative advantage. So just briefly to review, if you have absolute advantage, what that means is that you can actually produce the most, or in other ways it's oftentimes said is it's the one or the country, the firm, the person that requires the least amount of inputs to produce something. And again, that ultimately leads to them having the ability to produce the most. So absolute advantage, the easy way is look at who can do the most. And comparative advantage, on the other hand, is the one that can produce the good at the lowest opportunity cost. So one way of saying it is one that gives up the least to produce some good X, or in essence, the one that has the lowest opportunity cost, because they're giving up the least. And if they have the lowest opportunity cost, we say they have the comparative advantage in that good. And trade is based on that idea of comparative advantage. So just quickly, a few reminders about trade. One, gains from trade are based on comparative advantage. Countries that gain from specialization in trade will do so as long as there are different opportunity costs in the production of the goods between the countries. To gain from trade, again, you have to have a comparative advantage. Cannot stress this enough. So it's not about who can produce the most, it's about who can produce the good at the lowest opportunity cost. If trade is good for one country, real important to keep in mind, it does not imply it's good for the other country. Again, we have to have a situation where there's comparative advantage between all countries involved. And then another little note is that the workers and the firms in a domestic country that now have to compete with an importing industry, or in essence a foreign country now selling in the domestic country, are probably going to oppose this type of trade. So with those thoughts in mind, let's continue on. Okay, moving on to question 2. This question is probably the most difficult one in this chapter 3. And the reason it's more difficult than the other questions is because the information you're provided is not in what I call like terms. So what I've done here is I've typed up kind of a way to show you what to do. And just to overview, in the question you're given some information. So what you're told is what Naya can do in 3 hours. She's able to brew 1 gallon of root beer. And if she has 2 hours, she can make 1 pizza. On the other hand, Teresa takes 7 hours to brew a gallon of root beer and takes 5 hours to produce 1 pizza. So if you quickly look at this, it seems like Naya is way ahead of Teresa here because she doesn't take as much time doing either thing. And that actually means she has absolute advantage, Naya does, in both the beer, the root beer, and the pizza. But that is not what determines trade. What determines trade is who has comparative advantage or has to give up the least opportunity cost. So in order to, come to any sort of realm of whether that's even happening, you have to be given information in terms of same units, if you like. I like to put it of like. We've got to use the same increments. So I'm going to use, because I like using increments of 1. So we're going to use a 1 hour increment. So I'm going to scroll down and just kind of quickly go over this. So I'll try and be a little quick here. So again, she can produce 1 pizza in 2 hours, which means in 1 hour she can produce a half of a pizza. If it takes 2 hours to do 1, it takes half hour for each 1 hour. Naya can also produce 1 gallon of root beer in 3 hours. So if we want to put that in an increment of 1 hour, that means for every hour she's producing a third of a gallon. So a third in the first hour, a third in the second, and a third in the third hour gives you 1. So in 1 hour, she can produce a third of a gallon. So if we put what we just did here in terms of a formula, we can say that in 1 hour, there's an equal here. That for Naya, a half a pizza is equal to a third of a gallon of root beer because both of them take her an hour. And so now we can make a comparison. And then we can even go further and we can say, what if we wanted to put this information in terms of 1 pizza or in terms of 1 gallon of root beer? So what we would do is, like we've done in class, we're going to take this formula where half a pizza equals a third a gallon root beer, and we're going to make the left side, the pizza side, the number 1. So to make a half a 1, the number 1, you've got to times it by 2. So in math, whatever you do to one side, you better do to the other side. So what we get is 1 pizza equals 2/3 or 0.66 gallon of root beer for Naya. So in essence, for every pizza she produces in an hour, she's giving up a 0.66 gallon of root beer. If we do the exact same thing for the root beer, but now we want it in terms of root beer, we're going to flip the formula around And we know that 1/3 of a gallon root beer is a half a pizza. So now we want to make the left side the number 1. So in this case, to make 1/3 the number 1, you've got to times it by 3. So whatever you do to this side, you need to do to that side. So we find that a gallon of root beer is equal to 3/2 or 1.5 pizza for Naya. So now we're going to do exactly the same thing for Teresa. So reviewing the information we had on Teresa, we were told she can produce a pizza in 5 hours. So if we put that in increments of 1 hour, that means if it takes you 5 hours for an entire one pizza, that means every hour you're doing 1/5 of the pizza. So in 1 hour, she can produce 1/5 of a pizza. And then we were also told that she can produce 1 gallon of root beer in 7 hours. So if we want to know in 1 hour what she can produce, every hour she'd be producing 1/7 of a gallon. So if we put this into mathematical equation, we can now say, because we've got both of these goods in increments of 1 hour, we can say that if she produces 1/5 of a pizza, it's equal to a 1/7 gallon of root beer, because each one of those takes her 1 hour. So if we then wanted to go forward and then let's say get it in terms of what it is in one pizza terms, we do exactly what we just did for Naya. We're going to put the formula and make the pizza the number 1. So we know 1/5 of a pizza equals 1/7 of a gallon of root beer. So to make this left side the number 1, we got to times that by 5. That makes that 1 pizza. So again, mathematically, whatever you do to this side, you better do to that side. So this becomes 5/7. If you divide that out, it's 0.71 gallon root beer for Teresa. So this tells you for every pizza that Teresa's making, she's giving up a 0.71 gallon of root beer. And then we do the same thing for root beer. We want it in terms of 1 gallon root beer in terms of pizza. So we'll flip the equation. We know 1/7 of a gallon root beer is 1/5 of a pizza. So we want the left side to be the number 1. So we'll times that by 7, and that makes this the number 1. So we'd better times the other side by 7 to keep the equal sign. That's a mathematical formula. And so we end up with, for Teresa, that for every gallon root beer she produces, she's giving up 7/5 or 1.4 pizza. So the question then is, what's this all mean? So if we go down, I'm just kind of putting the overall. So now we have it in terms of pizza and root beer for both Naya and Teresa. And what we find is, and these are part of the question, so you'll want to, go over this. But what we find is that Naya, for every pizza, gives up 0.66 of a gallon of root beer, while Teresa has to give up 0.71. So comparative advantage is all about who can do it at least cost, who gives up the least. So we find Naya's giving up less root beer for every pizza. However, when we started out, it looked like Naya was able to do everything, more efficiently. But if we look at the incremental, we find that for a gallon of root beer, it takes Naya 1.5 pizzas. That's what she has to give up. While Teresa is giving up 1.4 pizza. She doesn't have to give out as much pizza for every gallon of root beer that she's making. So what we find is that trade can actually take place here and be beneficial for both. Because remember, Naya and Teresa both have a limited amount of time available to them. And so we have to make those choices. And if one of the two can do something at a lower opportunity cost, or in essence has a comparative advantage, then we need to go ahead and trade. Okay, now going on to question 3 and question 4. I'll just remind you, question 3 can be set up really easily because unlike question 2 where they weren't of like time increments, in this particular question you can go ahead and set it up pretty easily because it's of like. So you're told in England can produce 40 scones or 1 sweater, and and you're told in Scotland that they can produce 20 scones or 2 sweaters. So immediately you can go ahead and set up the little table that you'll use to then figure out who has absolute and comparative advantage. This is very much like what we've been doing in class, so I won't give you any more hints on that question. And then for question number 4, I would just have you go back to the reminders that were part of this tutorial on Chapter 3 homework, and I believe you'll be easily able to figure out which of those statements are true and false. So that's it for Chapter 3.